Is this gonna work or what? No.
I mean, we can. I won't do anything funky to your machine. Boop, boop, you're good. Okay. So.
Yeah. Which one is it? It's left, right. Okay.
Yeah. So the large button
It's
is
a bit
left
faded.
and right.
All right. No problem.
Is this on?
Testing.
It's on as well.
It's on.
Okay. Is this? Yeah, okay. All right, thank you, Nathan. Next up, we have Pierre presenting on cloud environments, red team perspectives.
All right. Testing. Everyone can hear me well? Yeah? It's good? For volume? Okay, cool. All right. I'm going to put myself a little timer. Sorry. All right, welcome to Cloud Environments Red Team Perspective. We're going to jump right into it. Who am I? My name is Pierre-Nicolas, Pierre-Nicolas. You can call me Pierre. I'm a senior penetration tester at Bell Canada's STIRT team. That is the security testing and incident response team. I do a lot of penetration testing, red team operations, purple team engagements, recently some cloud stuff, which you'll see in this here presentation. I also do a little bit of malware development for the red team purposes. And here are my two cats, which I have to mention. There we are. So, what's on the agenda today? Not all of these are equal, just a little preface. We're going to be talking about Cloud Security 101, cloud security challenges, offensive operations in the cloud, approaches and methodologies, standards and frameworks, the cloud attack lifecycle as we like to define it, leveraging the cloud as a red team operator, and finally, cloud security best practices. We won't be spending as much time on all of these topics, and I've practiced this a number of times and always come out over time, so I will be skipping through a little bit of the more complex stuff and try to get to the interesting stuff you may not have seen before. So, Cloud Security 101. I'm not going to spend too much time here because I'm sure most of you are at least somewhat familiar with what the cloud is, but cloud in very, very simple terms is other people's computers and infrastructure. Very simple terms. The three main providers, there's Amazon's AWS, there's Microsoft Azure, and there's Google's GCP. There are others, but they're pretty niche, so they will be outside of the scope of the talk today. And why do people use cloud? Well, all sorts of reasons, scalability, reliability, cost efficiency, accessibility, flexibility, all sorts of things. So again, a little bit of speed in these here parts. There are different AASs, as you may have noticed in your perusing of these documentations, SAS, FAST, PASS, IaaS. What does this mean? I'll resume it as, I like to think of it as different levels of granularity and capacity when it comes to using other people's computers and infrastructure, like I said. So you may be interested in simply using the processing power of a cloud, of a cloud setup and just, use only the function. You're passing it just a piece of code. You want it to calculate something, give you an answer. You're going to use function as a service. You might be interested in having VMs, actual full machines, in which case you're going to be using more of the infrastructure that's provided by the cloud provider. You might be using the identity service, as we're going to see a little bit later. So basically what these break down to is what parts of the infrastructure do you need access to, and you're going to subscribe to whatever it is that you need. This is an advantage of cloud because it gives you the flexibility to pick and choose on a cost basis and also on a needs basis what components you're going to be actually paying for and leveraging. An important thing to understand is that cloud does not equal not your responsibility. Okay, there's unfortunately, a lot of organizations that tend to assume that security in the cloud is not something that they need to consider because it's outsourced, it's someone else's infrastructure, and therefore it's not theirs to secure and properly configure. This is very much so not the case. Here you've got just a small comparison of different types of services that you might subscribe to from cloud providers versus on-prem. So if we're talking about on-prem, servers that are actually in your organization, your internal network, things you fully have control of, hardware that's in your internal network, in those cases, everything is your responsibility. But as we start using different cloud services, we start to have a shared responsibility model where security is both the responsibility of the provider and yourself. Although, like I said, it's never entirely their responsibility. If you start using, for example, Microsoft cloud infrastructure and you have a plethora of servers, yeah, those servers might be in a data center somewhere. The physical security of that data center is not your responsibility. If there's a fire, it's not your responsibility. But if you you create a bunch of accounts, configure them in a bad way, and an attacker gets access and starts to do nasty things, that's your fault. And that's something that you need to consider as an implication for your usage of these services, which leads into a couple of examples. I'm not going to go over these, but just to show you, there are major incidents that occur with regards to cloud infrastructure that can be extremely damaging to you as the user or to the parent organization itself. Going back in 2019, I just want to show that this happens, it exists, and also it evolves over time. In the past, we saw more typical, the types of attacks we were seeing were more typical web application attacks, starting a lot with SSRF attacks, server-side request forgery, really flaws with the APIs or the infrastructure itself that could be abused by attackers. In 2023, what we're seeing more of is identity-based leveraging, people finding permission issues between accounts, cross accounts, from different organizations that can influence each other, leakage of accounts, stuff like this. So it changes over time, something to consider. Jumping right into the meat of it, Azure versus Azure AD, I just want to get this said. Okay, Azure is not equal to Azure AD. They're not the same thing. It's very confusing naming, which is perhaps why they have moved towards changing the name, I believe, to Intra. But yeah, it's not the same thing. Azure AD is a granular component of Azure Cloud Services as a whole. It is really the identity service that is concerned here. And you will see it is not either a direct correlation to Windows Server Active Directory, which is a whole plethora of other things that are outside the scope of this talk. But I just wanted to mention it is not the same one-to-one thing. And we will talk specifically about Azure AD, but also a little bit about Azure as a whole. So this is just the vocabulary, getting it out of the way. Yeah, it is not Azure AD. Azure is Microsoft Cloud's platform, whereas the Azure AD is the Enterprise Identity Service. And we'll see what that implies in a little bit. Moving on to GCP, and get used to this. There's a lot of jumping around between the different providers. This talk is about the three main providers and the similarities and differences between them, but also, like the title suggests, the red team perspective. So I'm not going to talk too much about what cloud actually is. I'm going to talk about how we look at it from an attack perspective. But just to get this out of the way, GCP has its own IAM model, and essentially the domain that you would be familiar with is the company, and afterwards it's organized into folders which have various rights and permissions on projects. The projects actually then allocate whatever resources required. You can have things like VMs, you can have things like functions, whatever it is you need. Between these three providers, there's basically different naming schemes, but a lot of the same services. So you might see in AWS something is called an S3 bucket, but in Microsoft it's a blob, for example, in GCP you've got your compute engine instances, which are really just another word for virtual machines. So just to give you an idea, AWS, again, different organizations, different hierarchy, but similar concepts. Really, in this case, the tenants that you would be familiar with would be the accounts. In some cases, it'll be the organization, but not everybody does that. More or less frequently, we see accounts as being the root object that is in use, and that's what we end up targeting. Underneath, you'll have your resource groups with, again, various permissions. And then at the very end, you'll have your actual assets, EC2 instances, which are VMs, or like we just saw in GCP, cloud compute engines. S3 buckets, which are the storage, etc. So I'm not going to talk too much about that. But what does this imply? For an attacker, cloud infrastructure is a new way to get into your internal directory, or internal network, rather. It is a new internet-facing attack surface that opponents are going to leverage to do damage or potentially extract information from your organization. Typically, you'll see an example of a way into an internal network of whatever organization would be, just as an example, a web application that has a vulnerability. That web application, even though it might be vulnerable, might be behind a very strong web application firewall, WAF right here. So an attacker first has to contend with the web application firewall, then let's say they managed to get through it. Let's say they managed to exploit that web application. Now they have remote code execution on that server. Great. That server is probably in a DMZ. The DMZ is not directly connected to the internal network. They're going to have to pass through some firewalls. They might have to pass through, hopefully, some sort of network segmentation. There might be all sorts of countermeasures in place, CMs, IDS, IPS, all sorts of things that are going to prevent them from leveraging that level of access to then go and do big damage here in the internal network. One thing that attackers appreciate from the cloud is that it often gives direct access to the internal network and is not secured in the same way with all of these more mature countermeasures that you would be expecting from a typical internet-facing path. So basically, big takeaway, it increases your attack surface. It introduces new vulnerabilities. It is complex, and organizations have not yet caught up in the understanding of how to properly secure it most of the time. There are some detection and response tools that function at this level, but they're not very widely implemented, and they're often not well understood, but they are starting to get there. And it also gives access, something that isn't often considered, but it also gives access from the internal network to the cloud. So an attacker who has already compromised a workstation, say one of your employees opens a malicious email, downloads a payload, detonates it, and now you have remote code execution on that asset. Well, now there's a new way to get more, let's say, goods out of that position that you're in. You might be able to extract information that previously was not available because you can leverage the fact that the internal network is connected to the cloud environment. So it also adds new paths to further compromise from the internal perspective as well, not just from the outside. So there's basically a whole bunch of new attack surface that's opened up by this. Cloud environments present challenges for attackers as well, of course. There are new systems involved, and we need to understand them in order to hack them. There's less opportunities for traditional types of attacks like MITM. For example, one of the bread and butter things that we do in internal engagements is man-in-the-middle poisoning type attacks that leverage deprecated resolution protocols like LLMNR or multicast DNS or NetBIOS name resolution, and more recently IPv6 poisoning. You can't do any of that sort of stuff from the cloud, right? It's just a different position that you're in. So you have to rethink your tools and tactics. But it can still be incredibly useful. There are different IAM models between the major providers, which can be a whole headache, and which I will skip over in this presentation because I just do not have time to explain it all. But you'll see, at least from the slides, that there is a considerable amount of complexity there. And you need to stay ahead of the curve as an attacker because a lot of this is not documented or poorly documented or only documented by other hackers and changing all the time. And since it's not documented, these companies don't necessarily have any reason to tell you when they change an API call, the structure of it, or what have you. So basically, the research is not well defined yet. It is getting there, and there is some good resources available online, but it's not yet fully mature. And this, of course, presents a challenge for attackers. So I said I would skip this part. I'm just going to mention it very, very briefly. AWS, GCP, and Azure have different IAM models. There are basically users in all of these cases. There are roles and permissions in all of these cases. And typically, there are service accounts in all of these cases. Service accounts which are tied to the usage of applications or resources that you're using in these cloud environments. And then users which are users, as you may have guessed. I'm going to skip through that part. Why does this matter? Without having explained the IAM model, this is a cheap cop-out, but either way. This is a typical example of something that is not considered by a company. So down here, you have your pen test account. This is a compromised account in our example company. It has reset password permissions on the SVC backup account. This is something you might see in real life, actually. The SVC backup account was used to create an application in Azure. So it is the owner of this application in Azure, the data platform application. And the data platform application is running as this data platform service account over here. This is usually something that will be done because, first of all, the application needs a service account to run as. And second of all, application creators are going to be attempting to create segmentation, at the very least, from their account that they've used to create it with the account that the application uses to do its various services. What isn't considered, and why IAM models are so important, is because of this relationship that allows for takeover. Because you can reset the password here, and this guy owns this application, which is running as that user. Essentially, this user owns that user all the way in the corner. If this user, which is intended to be the one that the application runs as, has certain permissions that the application needs in order to function, that can be leveraged by the attacker who has compromised the first account. In this case, you can list all the details and download items from OneDrive users based on these fairly common permissions that you might find an application having. Now, you can imagine that as an attacker, you get access to an account. Now you can download all of the OneDrive information. That's pretty powerful, and you might be able to recycle that information, find new credentials, secrets, processes, et cetera, and leverage it to further your attacks. So just a little precursor. All right, Cloud CLI. There's many ways to interface with these cloud services. Azure by far is the most complex. It has a whole bunch, and this isn't even all of them. Some of them are legacy and deprecated, but I just wanted to mention that there are a bunch of ways to interact with these services from command line, or essentially. So that's all I wanted there. Now, moving into the crux of the material, consider that to be the intro. So, cloud offensive operations. At Bell, what we've done is we've split this into 3 different types of categories. We have penetration testing, we have cloud offensive operations, and cloud purple team exercises. So penetration testing, we split it into 3 tiers. There's a black box, a gray box, and a white box approach. They complement each other and are not either or. They're often all required in order to get a good coverage of the application. I'll explain why in a bit. Red team operations focus on specific goals, and typically we're going to use a plethora of different tactics that might be a little bit more advanced or invasive, depending on the scope and rules of engagement that we've agreed upon. That would include social engineering, it would include phishing, and it would include perhaps even moving on site if it's required. And purple team exercises are going to be sort of like a red team, but with more of an emphasis on collaboration with the blue team or security operations center of the client, where we're going to try to help them come up with better response and detection methodologies and see where they're lacking when we do certain actions. So different goals in these types of events. The methodology, like I spoke about, we split the pen testing into 3 different components: the external, the assumed breach, and the security audit, which is the different box colors. So the reason why we do this is you might have a black box engagement that occurs, and we look at your profile on the internet, we do our OSINT methods, we don't find anything. There's no exposed credentials, there's no badly configured services that are visible from the outside, there's nothing we can do to get a foothold. But you might have some server that is very, very poorly configured, and the day that there is someone who gets an account, maybe some person in your organization clicks on a link or does something bad or changes their password and reuses it somewhere else and some website gets breached, whatever, there's a reason why we have a way in now. Well, the day that that happens and you've only done black box perspective, you might think you're fully secure, but you're absolutely not. So what we do is we include this gray box perspective, which will leverage an identity that has been provided that represents our standard employee, and we'll see, okay, if this standard employee gets breached, what's the worst that can happen? And often companies are surprised to see what is the worst that can happen. They might be expecting, because from an external point of view, there is no current low-hanging fruit, then there might not be anything to find, but that's often not the case. Similar rationale is applied to the white box perspective. So when we do the white box, we demand, or we ask for a high privilege account, which has access to everything in the cloud environment. And then what we're going to do is we're going to systematically audit everything to see, okay, we might, in those cases, it might give us visibility on certain assets that we just would never even see if we were using the employee account. That can be important when you're dealing with assets that have, say, random alphanumeric subdomains that's like an MD5 hash or something you will never find or guess programmatically. And now you have access to it, you have visibility on it. Oh, look at that, it's terribly configured. It's easy for an attacker to do an incredible amount of damage with it, etc. So this is a bit the ideology behind splitting this into 3 different tiers. And again, they complement each other. They aren't replacements for each other. So standards and frameworks, I'm going to talk just a little bit about this, and I'll explain why. MITRE has some good stuff. They're very good at making matrices. We are not going to talk too much about the matrix because there is, when it comes to cloud, in my opinion, there is a lot of overlap with the different steps. And also the steps are not so much sequential as you would expect them to be. Sometimes you have a step that skips another one. Sometimes you have one step which takes 3 steps in one, and this is often the case. So I just wanted to mention that MITRE has some attack frameworks for cloud specifically. Microsoft has their own, and there are some in the community, like Lena Lau has a good one on GitHub, which is available. So there are some ways to understand this, but I wouldn't use this as a rigid framework to base your understanding of cloud pen testing on. It's more of something that can complement it. Although we will do some callbacks to this framework here. So this is the cloud matrix framework, and it breaks down in its steps. If you don't know, there's the initial access, excuse me, the execution, persistence, privilege escalation, defense evasion, credential access, discovery, lateral movement, etc. You'll see in my examples later why this isn't so much a good thing to base yourself on rigidly, but it is helpful to understand the overall process, and it will be referenced in this documentation. So let's get into the meat of it. This is the actual reason why I'm here. So cloud attack lifecycle. We've got the first step, which is identifying the target, always. In the 3 different cases of these providers, it's going to be either identifying the organization name, the AWS account ID, or the tenant ID, which is basically the same thing. It's an identifier which represents your cloud environment that you are leasing from the cloud provider. That's what we base our initial attack on, and everything that comes after is based off of this discovery. The first step, so again, I said I would reference MITRE, right? But you'll see why. So the first step, initial access. It occurs in one of 6 ways, typically. We either exploit a cloud component, which is a VM, a function, some storage buckets, whatever. Exploit an identity, which is leaked. It could be an access token, or it could be actually credentials. Spraying, which can be username, brute forcing usernames, password spraying, etc. Phishing users for credentials or to bypass MFA. Exploiting a device. It happens when we already have access to your internal environment, but maybe we aren't a domain admin. We might not have all of the keys to the castle. We might just have a very small foothold in your internal environment. Maybe we just have one user or one workstation that's been compromised. But if that workstation is joined to the cloud, and there are ways for us to bounce into the cloud and then back into your internal environment, or just into the cloud and get some secrets there, this is one way that we would get initial access to the cloud environment. And abusing trust relationships, specifically supply chain attacks or trust relationships that exist between different organizations or tenants in different cloud environments. You've got some examples of this here. So DNS enumeration, certificate transparency lists, classic OSINT stuff. That's open source intelligence gathering. I'm going to use that acronym a lot. But this is where we would essentially grab a list of valid targets and things of the source. Search engine indexing, so dorks. There are Google dorks, there are Bing dorks, there's pretty much any search engine has dorks. These are specific operators that let us search for very specific information that's been unintentionally indexed by these great services. This is actually a functional dork, so if you use this right now, you will find creds on the internet to some organizations that I have no affiliation with. But yeah, this is actually working as of this morning. And it's just to illustrate the point. We would, of course, refine these and include keywords that relate to the specific target. We're not just looking broadly, but you should be aware that attackers are looking broadly and will eventually find things that are leaked. So that's a good example. Publicly accessible storage, so S3 buckets, cloud storage, Azure blobs. There are aggregation websites and services that exist to find these, like Grey Hat Warfare is a good one. Here on the left, I should say, there is an example of a Python tool, which is open source, available on GitHub, which allows identifying open S3 buckets. You give it a keyword. In this case, the target is dev-cloud-buck, which is a target we created for this presentation. And we configured a S3 bucket to be accessible publicly. So you can use this. It'll do some rudimentary brute forcing and permutations on the name to find open buckets, and then it'll list them for you. And then here you've got an example of some goods you would find super secret key. You can imagine this would be an SSH key. It might be some random documents that disclose information about your internal processes. Could be anything. But if it's open, attackers will find it if they're targeting you. Traditional web application vulnerabilities is another way in. Usually you'll see this when cloud components are implemented into web applications, like cloud functions, for example, might be used as a backend for an application, or maybe the application itself is hosted on a cloud VM. So if we can exploit that application in a traditional way, we will have execution in the context of the cloud account that is running it. So this is another way we get initial access. Open services, this is typical normal stuff. If you have a cloud VM and it's running certain deprecated or vulnerable services on certain ports, or maybe it just has an open port, where you can connect and do some nasty stuff, well, we can find that just as if it was a regular physical server. Same thing. There's also vulnerable serverless functions. I already went over that. Leaked credentials, there's great tools that allow you to find leaked credentials on the internet. We're going to spend a bit more time on these, so I won't talk about them now. Password spray, also going to talk more about these in detail. System compromise, this is like when you're in an internal environment and you have system on an asset, server, workstation, whatever, you can extract a primary refresh token, for example, from the computer itself, and then use that to access the cloud environment as that computer's account. So you can also do phishing, which we'll talk about, again, in more details in a sec. So let's move on. Here you've just got a couple of specific examples of for each one, so AWS, Azure, and GCP. You see here it's pretty much the same thing. You can exploit public VMs and snapshots. This one's actually kind of cool. Lots of companies will have snapshots or volumes of certain assets that are accessible on the internet. That belong to assets that are either in the cloud or that are not in the cloud, that are in their internal environment. We've actually seen this in practice where an organization will have, for example, a snapshot, backup of their domain controller VM. And then that is hosted publicly in the cloud. But the domain controller is not connected to the internet. Well, if we can get that snapshot, which is publicly available, we can set up our own computer in our own cloud instance and then just mount that, and we have full control of our own computer, and we just own your domain controller. So this is something we see often. Also, when you get access to a particular server, you might be able to find certain tokens, right? These are just paths that you would look for in different cases, but it's, as you can see, the same thing. It's just a different path. You'll find tokens there. Tokens are cool because they often allow you to bypass MFA because there's kind of an assumption that you've already passed through the MFA transaction in order to acquire them. So there's limitations on how they're used, but they can be pretty much equivalent or better than credentials in some cases. Okay, so more on access tokens. We can search for these also on the internet because they follow certain patterns. In AWS case, they all start with AKIA. This is a pattern that we can leverage to programmatically look for them. There are services that exist to leverage that. And we can also find, for example, in the case of GCP, like JSON files, which are service account JSON files, which are essentially equivalent to accessing that service account. In the picture you have here, the example is us using the legitimate Google Cloud CLI to upload or to actually use the IAP-SA JSON file that we have recovered off of the internet. So it was publicly accessible. We found it by searching for it using OSINT again. Well, we can activate that account, and now we have access to the projects that account has access to. So these are just some of the ways that you can leverage these things. And there's a couple of tools here at the bottom. I encourage you to check them out. Some of them are very good, like TruffleHog, for example. Very good tool to do this. Other ways that we get initial access, and it's going to be like this, guys. I'm going to go through them fast. I'm trying to give you red team perspectives, not teach you everything about it. So initial access, another way we can do it is through user enumeration, particularly in the case of Azure, because Azure doesn't consider this to be a vulnerability. Rather, Microsoft doesn't consider it to be a vulnerability. So they allow username enumeration to continue to exist. It's kind of a by design thing. So yeah, in this case, we're using CredMaster, which is all these tools, by the way, all available on GitHub, all free, all open source, et cetera. In this case, what we're doing is we're creating a list of potential users. We're going to do that through, again, OSINT. We're going to look at your company's LinkedIn. We're going to look at your company's website. We're going to grab all of the employees' names, everyone who has anything to do with your company. We're going to derive the structure of email addresses that your company is using. So typically, it's like first name dot last name, or the first letter of the last name and then the first name. Whatever. These are predictable patterns. We'll create lists of users of usernames based on these patterns, and we will feed it to these types of tools. These tools, in this case, this tool is leveraging AWS infrastructure in order to do this. So we're using AWS and a technique or a tool called FireProx, which basically we create an API gateway and we rotate the IP every time that we make a request. So we can avoid lockout policies this way. As we move forward in time, these companies are getting, or these providers are getting better at detecting this sort of thing. So we also have to add certain randomization, like user agent randomization, to make it look like it's coming from a different device by adding different HTTP headers. We also have to add jitter to the time intervals. Machine learning is getting better at seeing attacks, so we have to add a little bit more randomness to the attacks, but it's still entirely possible. So in this case, we're using a specific region, which looks legitimate, and we are trying all of these usernames until we find some valid ones. Everything's blacked out, but the idea is we take a list that we've created and we find valid usernames. Then we do the same thing with passwords until we get a hit. And in this case, we're doing, again, the same thing. You see we've added a delay to the command, but again, this is just an arbitrary tool. You can use any tool to do this. You can make your own tool. We're using a specific region, and we're rotating the IP, again, every time that we do these requests. So here you see we have some valid ones. OK, cool. So we've done some password spraying. We've found some users. Now what? What if there is MFA? MFA is, in this case, and typically, based on conditional access policies. In this case, conditional access is an if-then statement. So it says if you want to access a resource, then you have to complete a certain action. This is typically how multi-factor authentication is implemented. So there are a number of ways to get around it. Usually has to do with misconfiguration. We are using a tool called MFA Sweep, again, free, open source, GitHub, which can be used to test what are the factors that force the use of MFA. There are sometimes exceptions, and we will leverage those exceptions as an attacker. So these are the typical exceptions. You've got legacy authentication. That means old protocols that just don't work with MFA. They break, so we create exceptions for them. You've got geolocation-based. I skipped one. I'll get back to it. You've got geolocation-based. So anything from China, deny it. We are in the US. We're not going to let that happen. Device type, right? That one is something that MFA Sweep will be able to detect. Perhaps all of the C-level at your organization uses iPhones, and they can't be bothered with MFA because it reduces their productivity. I've seen that. So they make it so that all iPhones don't have to use MFA. Or maybe Linux devices because it breaks, whatever. There's also user-based conditions. So there might be groups within the cloud environment that are specifically allowing this. Again, like execs, IT, break glass accounts. So accounts that you'll use if you're locked out of your cloud environment. You might not want MFA on that one account, and it's actually kind of common to have that. And also cookie or access token hijacking. Usually these will bypass MFA altogether because, like I said earlier, there's an assumption that you've already passed through the appropriate channels. In this case here, we're using MFA Sweep to detect which cases are required or not the use of multi-factor authentication. We see that Linux, Android, and iPhone do not need it. So we would then emulate those user agents or those devices and use them to access this account that we previously found without passing through multi-factor authentication. One thing that I didn't mention, and that I'm going back to it, the wireless guest network thing here. Another way that conditional access policies are applied for MFA is through IP ranges. Typically, an organization might say, OK, all the exit IPs of our internal network, we are going to make it so that they don't have to use multi-factor authentication because we trust that the people are sitting at their desk. We know who they are. We already have cameras and security guards and all this, so it's fine. They don't have to use 2FA. Well, in that case, something that we've actually seen in practice and that occurs is they'll include accidentally or through neglect the exit IP of their guest network, which happens to perhaps overlap in range with what they're usually using for their internal network. So what we can do then in those cases is we can drive up to the company, go in the lobby, sign into the guest network with no creds, and then use these accounts that we've derived creds for and bypass MFA because they've allowed the guest network to do so. So this is a good example of things not to do. Other perspectives, right? Switching up a lot, but for initial access, something that we will do often is leverage communication apps, things that are built into the cloud environment themselves. things like Teams or Google Chat. By default, Google Chat will allow communication from an outside organization. Same thing with Teams in a lot of cases. We can create a very realistic outside organization which mimics or looks identical to something that the user is expecting to see, perhaps a subsidiary, perhaps the same organization itself, but with a small change in the letters, whatever. And then we will send them basically spear phishing. What's cool about this, as opposed to traditional email phishing, is it often bypasses all of those traditional countermeasures. Remember the graph at the beginning where there's all those countermeasures that are in place, but not from the cloud environment. So a lot of people are not protecting against this sort of thing. Although they might have a very good anti-spam filter, they might have deep packet inspection, and they might have a firewall which is stopping resolution of malicious host names and all this. But if we use these, which are legitimate tools that are not watched, we can get past those things, send a malicious link, and then do our thing that way. So this is something we might leverage. AWS assume role abuse. This is more specific, but also pretty cool. AWS in particular, now we've moved on to a different one, has policies which allow for assume role, which is basically an impersonation. The assume role action allows you to take that role that you're asking for through the API. Because of a discrepancy between the response when you ask for a role that doesn't exist or that does exist, we can brute force programmatically a bunch of roles like write access, full admin, global admin, just stuff that might common sense be in use. And we will determine which roles actually do exist at that organization. If any of them are configured as follows, like with principal and then a star, meaning anybody, we can, after that, take our attacker organization, which also exists in AWS, create an account, and then assume that role. Since we know the name of the role, we've brute forced it, and it's misconfigured, we can give that role to our attacker account. This can be very dangerous, and it occurs in practice as well. So there's tools to help with the brute forcing components of this, although you could just do it yourself. Just a little example of another initial access technique. Now moving on to Azure. Again, we're spending a lot of time in initial access because red team perspectives. We just want to give you guys a little bit of an eye-opener. So illicit consent grant, this is a really cool one. We basically create a new tenant in Azure, and we create a new application that is attacker controlled. The application, we are going to abuse delegation between the victim and that application. And we're basically going to generate a link which is going to ask the victim to delegate their permissions in their Azure organization to ours, to the application specifically. And it would look something like this. So this is the crafted email. It looks very legitimate. When they click on it, they get this legitimate, like not crafted, this is a real Microsoft pop-up asking for consent. You can see the company, like the attacker company that we've created is MSFT Security Services. Up there, looks very realistic. We're using the Microsoft logo. The only indicator that this is malicious is that it says unverified. That's it. If they accept, they are going to be essentially sending us their access token and refresh token. The access token has a short lifespan. We can use the refresh token for up to 90 days to reobtain the access token. And we would get whatever permissions that they have accorded to the application. So that user, if they have certain permissions on certain things within their cloud organization, now we have access to that as well. So this is pretty powerful. It's been partially patched since 2020. There are new countermeasures in place, like the warnings changed basically, but it still remains exploitable and pretty much the same. Another type of leveraging of legitimate Microsoft infrastructure in order to do phishing is device code phishing. So this link here, Microsoft device login, exists for devices that are not smart devices, that don't have a web browser and that you want to enroll in your Azure services. So we can use those to create this here code, and then we can send that code to the victim in an email that looks like this. If they click on the link, it sends them to the legitimate device code enrollment endpoint from Microsoft. They enter the code that we've provided, and then it, again, gives us an access token and a refresh token to their instance. The only difference here is we can't control which permissions we want. We are going to get just basic permissions, but they are enough to, for example, list all of the users of the Azure environment. With all those users, we can then go back into the first stages and start attacking those users for password sprays or other types of things. So it would feed into the attack lifecycle. Moving to persistence. So this is changing up the MITRE framework a little bit. There are many ways that we can get persistence. And a reason why I mentioned I don't like the MITRE framework to describe this fully is because oftentimes you won't be able to get persistence after your initial access. You have very low privileges. You don't have the ability to modify some of these things that would allow you to get persistence. It doesn't always make sense to have it as a second step. You might have to do privilege escalation before you get to persistence, or perhaps you're going to do an action which allows you to get persistence and privilege escalation in the same go, and thus it's not necessarily the best way to split it up and look at it that way. In this case, however, we're going back to what we saw earlier, so the assume role thing. Well, we can, instead of creating a new service principal or a new account in your compromised environment, we can actually just modify this, this trust policy and create that vulnerability that we spoke about earlier. Instead of putting a star, this time we're putting literally we're designating our attacker account from our external organization, and we're pretty much backdooring this in the sense that we can assume this role now at any time with that attacker account which belongs to our external organization. This is something that might not be as visible to sysadmins or anybody who's managing the cloud infrastructure. So that's what we've got here, assume role policy backdoor, but there's other things that we can do. Running out of time, so I'm not going to talk about all of them, but we can modify the conditional access policies. We can hook Azure AD Connect. That's pretty cool, but way outside the scope of this talk, but we can basically mess with the DLLs that are causing the synchronization from the internal environment to the cloud for the password hashes. We can assign virtual machine contributor role to a compromised user, which means that basically these contributor roles are very, very powerful, and we can do a lot of things with them. I'll leave it at that. Attach policies to a compromised user, backdoor Lambda functions, those are cool too. We can add our own code to an existing function that's being used that's being provided by the cloud environment. We could also, in GCP, for instance, add our SSH keys to the project metadata. Then any resource that's created with that project will automatically incorporate our SSH keys, and we can log into it with those. A bunch of ways to do persistence. Privilege escalation. I'm going to touch on this very briefly. There are a number of ways we can do privilege escalation as well in a cloud environment, and IAM and roles and permissions are really the most important thing to consider when you're doing your configuration, because if we have almost no permissions or we have no permissions when we get our account, we can't do anything with it. It really comes down to that. If, for example, here, we're giving an example of implicit delegation, which is a GCP thing. But this is reminiscent of what was previously in the beginning of the talk. If you have service account A, which has implicit delegation on service account B, and service account B has get access token or whatever privilege over service account C, then A also has that privilege over C. And this is something that is not always taken into consideration. So there may be segmentation in place with the intention of making this impossible, but because there's implicit delegation between A and B, A controls everything C controls. This is a reductionist view, but if you took this and made it more complex, you might have 10, 11, 12, 20 different accounts, in this chain. But implicit delegation, or any type of delegation for that matter, can lead to this sort of escalation potential. There's also there's also acting as a service account. I'm not going to explain too much about this. Just wanted to briefly mention privilege escalation. Credential access. Moving further down the MITRE framework, we might, red team perspectives, so again, not too much overall information, just trying to open your eyes a little bit. To get credential access, let's say we've compromised a virtual machine which belongs to a cloud environment. There's a web app running, and it's running on a cloud VM. We get RCE on the VM through the web app. Now we have RCE as a user that was running the web app, or perhaps as a normal user on that VM. We can perform SSRF attacks to get credentialed access as the VM itself. In the case of Azure and GCP, they're very similar. You can see basically here what we're doing is we're using PowerShell to make a request to this non-routable IP. You could consider that IP as like sort of your 127.0.0.1 in a traditional, or localhost, in your traditional SSRF attacks. So we will make a request and obtain a token as the actual instance itself, and then that token becomes our credentialed access for the VM. So we don't necessarily have to have initial credentials in order to persist in that case. And there I use the word persist, but you see credentialed access would lead to a persistence. Or in the previous case, the privilege escalation could lead to a persistence. And that's again why I didn't spend too much time on the MITRE framework, or any framework for that matter. And you can do the same thing in both cases. There are a number of ways to get credential access through abuse of Intune. This is Azure again, Intune, or if you are a global admin device configurer, there's a lot of different ways you can do that. I'll give an example here. If you're Intune manager, Intune administrator or a global administrator, you can execute PowerShell on the joined assets. So in this case, we could execute something that would give us access to secrets that are stored on the box. We could create users on the box. This would give us a persistence mechanism. It would give us credentialed access, and it would give us the ability to provisk as well. So again, 3-in-1, not so strictly one-to-one, these MITRE steps. Exfiltration, going a bit further down the line. There's a number of ways we can do exfiltration. We can create images, volumes, snapshots. We can host things in buckets. We can synchronize buckets. There's all sorts of legitimate functionalities that we can abuse that exist inside the cloud infrastructure that would allow us to do this. In this case, we're creating an image, and then after we will host that image publicly and then take it and we can mount it into our own VM or our own instance in our attacker-controlled organization, and then we can recover that information that way. And finally, impact. So here's some things that are not typically considered, and we've actually seen these in real life. So if you can edit the key policy in an AWS account, you might be able to create your own AWS account, go into your KMS, create a key, and then change the policy of your victim so that you can import your own key into their organization, and now you can encrypt all of their S3 buckets with your key. If you do this, this is really bad for the victim. Essentially, this using the legitimate AWS infrastructure as ransomware, and there's nothing they can do. If they were to contact Amazon and say, hey, I can't access my S3 bucket, they'll say, yeah, well, all the data is encrypted with this key. Does it belong to you? No. Oh, okay, it belongs to this external organization. Nothing they can do there. They don't have a backdoor into this, hopefully. So there's no way for them to then get access to that information, and you'll be in a whole lot of trouble. So this is something to consider as well, and one of the potential impacts that could occur if you are attacked if your infrastructure on the cloud side is attacked and attackers succeed. So I'm going to talk quickly about leveraging the cloud as a red team operator. These are more features that we might use in red teams. I talked about Fireprox and how we can use AWS API gateway to rotate IPs to do all sorts of interesting things and avoid countermeasures. I'll also talk about quickly cloud-based phishing. So we saw two types of that: illicit grant attacks and consent grant attacks, rather, and device code phishing. There are more. I just mentioned two briefly. So these are things that go into the TTPs of attackers, modern day attackers. Also using cloud for making your C2 infrastructure better. As an attacker, we often need to obfuscate our command and control servers because they're giving off a whole lot of signatures that companies and defensive products are used to detecting. So one thing that we'll do is we'll leverage legitimate Azure infrastructure. We'll configure some redirectors so that our implant, let's say Cobalt Strike Beacon, or in the case of less mature engagements, maybe like a meterpreter might be something that people are familiar with. But whatever your implant that detonated is, it needs to talk back to your command and control server. If we do it this way, which is a technique called cloud fronting, we're basically going to make it talk to Azure instead of directly to us, and then Azure will redirect everything to us. This means that from an internal perspective, if you're monitoring logs, if you're a CM, if you're a firewall, all you see is communication with Microsoft, with legitimate Azure endpoints. And that's, if you've spent any time in internal networks looking at traffic, it's impossible to separate some communication with Microsoft from other communication with Microsoft. And if it's properly done, it can be able to bypass even next generation countermeasures. So this is something that is being done in practice. It's very common, and it is quite effective. So we can also host malicious code on Azure and S3 instances, which can help when we want to recover. If we're doing a staged payload and we need to take different pieces from it, if we put it in S3 and you guys are flagging any malicious domains, well, it's talking to Amazon. It's not talking to a malicious domain. So these are ways that we can leverage the cloud as a red team. And finally, this slide, because I had to include this because you guys need something positive. So there are ways to stop this, right? You need to understand the shared responsibility model first and foremost. You need to start with the configuration, and really, pen testing services can help with uncovering these types of flaws. and they can be rather esoteric at times. So it's good to make use of those services. Not enough companies do so frequently. It's cool to also deploy MFA, even though I talked about ways to bypass it. It's absolutely very, very useful and a very large stop gap, that can help you secure your infrastructure more. In fact, all the things that we talked about earlier are specific instances where MFA is bypassable because it's not properly implemented. So when it is properly implemented, it can be very useful. Regularly review access token usage. This is something that not enough people do. There might be 2 or 3 or 4 access tokens that are associated with an admin account. We ask the sysadmin, hey, what's up with those? Oh, you can delete those, haven't used them for a year or 2. Why do they exist? If they're being used, you wouldn't necessarily be aware of it. So review that. Inventory your apps, monitor privileged accounts, review and audit service principals and the permissions that they have in things like MS Graph API, fine-grained identity and access management. Essentially, there are ways to make this better. It's not all bad. And one cool thing can be deploying honey tokens and honeypot accounts so that indexing services that we're relying on when we do our OSINT, they might be finding those. And then if an attacker uses it, you're aware that someone is targeting you. So it can be cool to intentionally leak some of these things as long as it's properly done and they don't actually give access to anything to alert you that you're being targeted and in what ways you can improve. So yeah, that's pretty much it. If anyone has any questions, I am available for -5 minutes.